so I'm Randy Knippel. I'm the GIS manager at Dakota County, but I've been involved with the Emergency Preparedness Committee for a number of years and promoting the U.S. National Grid. We mentioned the Wisconsin Land Information Association, where we gave a workshop, and BJ Kolstad participated in that workshop presenting as well. And normally, so I'm going to be talking today really about making maps for the U.S. National Grid. And when we did the workshop, I preceded this portion with a 45-50-minute presentation on an introduction to the U.S. National Grid. I've got a few intro slides on the U.S. National Grid, but my assumption is that you already know about it and that I don't need to sell you on the concept. So I'm making that assumption. It may or may not be true. But we don't have the time to go into all the detail on the background information. Essentially, the U.S. National Grid is a national standard. It does relate directly to what we do with GIS and cartography. It's incumbent on us as geospatial professionals to embrace it and promote it. So there really is no argument, no valid argument against it. So this is about maps, and while in GIS we do a lot of fancy technology stuff, this is the foundation of what we do is creating maps. And it's not just about creating maps, but then it's also about creating maps that are consistent across jurisdiction, and then providing the training that goes along with that. So we teach people how to use maps, how to read from maps. It's basic map reading and land navigation skills that you can do in about an hour. It's taught to every recruit in the military. We need to do the same thing with first responders and emergency managers, essentially giving them precision tools that they can use for measuring and describing locations, and how that integrates with GPS and with mobile apps and simple things like a protractor and measuring device. So this is what we need to teach people, as well as creating standardized maps. And the reason we do this is because the Earth is round. This whole science of mapping was developed because we need to have a way of presenting a spherical surface onto a flat surface. And so even though it sounds like it's really simple in creating these maps for people to use and teaching them how to measure, it's all based on solid science and solid geometry and geodesy, so that the measurements are done accurately. And that's really what this is all about. Taking a complex problem and simplifying it and standardizing it. And we can see this in the products that have been generated for years from the USGS. These are the US topo maps. They put UTM coordinates on their maps. The US National Grid is nothing more than a shorthand notation for UTM coordinates. So this has been around for a long time. If we just take a quick look at US National Grid coordinate format, you can see the 15 TVK 922-220-76580. That is shorthand notation for the UTM coordinates you see at the bottom. And what you see is that some of the digits on the left are replaced by some alphanumeric characters, and that's all a part of the simplification. So the first part is the grid zone. You'll see 15 is UTM zone 15. The T just breaks the UTM zone into 8-degree sectors. The second represents the 100,000 kilometer square, or even 100,000 meter increments of UTM coordinates. And then we have an even number of digits for the X coordinate or the easting, and an even number of digits for the Y coordinate or northing. And that becomes the most important part, especially when we're working at a local level. It means that we always have an even number of digits, and we can start to make some assumptions about that based on the number of digits that we have. And these are always going to be in meters using UTM coordinates. And we can see the standards applied when we look at the maps. They'll all have this kind of a block someplace in the margin area that references the grid, the datum, the grid zone designation, the 100,000 meters square, and so on. And that's all a part of the convention for creating U.S. National Grid compliant maps. So this is all about breaking the U.S. into smaller pieces that can then be referenced using these U.S. National Grid coordinates. And there we can see UTM zone 15. Overlaid on top of that are the 100,000 meter squares of UTM coordinates. And you can see they have alphabetic characters, and there's actually rows and columns. So you can see all the columns of L, M, N, and so on. And then you have rows of the same alphabet, G, H, J, K, L. I's and O's are omitted so they don't get confused with letters. Um, but that means that when we're working at a local level, we don't have to continue to refer to the 15T because we know we're working in Minnesota, and we don't have to keep referring to the 100,000 meters square because we were probably working at a localized level. And so in Minnesota, if we're looking at VK, for example, or Victor Kilo, as we're supposed to reference it, we can see that resides in Minnesota. So once we're working at a local level, we don't need to continue referring to 15T all the time because we know that VK is unique within Minnesota. In fact, VK, Victor Kilo, is unique within 800 miles of any direction. And so that's where we start to create some of the efficiencies in using the U.S. National Grid. If we just break that down, so here 15T is the UTM zone. It's a 6 degree by 8 degree sector of latitude longitude, and it falls within a UTM zone. Then on top of that is the UTM coordinate system. It's a rectangular system that's overlaid on top of those sectors using a standard projection, and then given an alphabetic notation, and you can see the rows and columns of the alphabet there. And so that represents a 100,000 meter square, and it really is defined by the coordinates of the lower left corner. The UTM coordinates of the lower left corner are going to be an even 100,000 meters in both directions. And then we start to break it down further. So now we look at the numeric portion. When we're looking at the first two digits, the first digit in X and the first digit in Y, we're looking at a 10,000 meter square. And again, it's in the even 10,000 meter coordinates of the UTM coordinate system defined by the coordinates of the lower left corner. And the same continues. We add 2 more digits, and now we're at a 1,000 meter square. Again, even 1,000 meters on the lower left corner. These squares are always defined by the coordinates of the lower left corner. So we're always talking about an area, essentially. Add 2 more digits, and now we're at a 100 meter square. Add 2 more digits, and we're talking about a 10 meter square. You could go further to a 1 meter square. Another thing that happens, this is all base 10, so you have 10 subdivisions in each direction within each of these squares, and that's pretty easy to visually interpolate and measure with your finger to be able to use the grid to define a location that's a bit more precise than the grid itself. And it's pretty easy to do. Most people can figure that out. All of the USGS topo maps are US National Grid compliant. These are 7.5 by 7.5 minute quadrangles or quad maps, 1 to 24,000 scale. They're available nationally at 1 to 24,000 scale. These are GeoPDFs. They also have layers that you can turn on and off. So you can go into the layers in Adobe Acrobat Reader and be able to manipulate what you actually see and print using those maps. Point here is that there are US National Grid US National Grid compliant maps available for the entire country. And they're all out there at 1 to 24,000 scale. You can start using them immediately. You don't have to make your own maps in order to start promoting the use of the US National Grid. And at the fundamental level, it means put grids on your maps. Whatever maps you're creating, we never know in an emergency situation what map might get pulled out of the drawer and put on the table for somebody to use. And so we want to make sure that the maps are interoperable for determining and measuring locations using the US National Grid. So we want to put UTM grids on our maps regardless of their purpose, and really promote the awareness and use of those coordinates. And here's just another example. This is Camp Ripley in Minnesota, US National Guard camp, again with the US National Grid map as a training map. Here was a map for the National Emergency Training Center in Emmitsburg, Maryland. Similarly, you're showing the grid and making it National Grid compliant. In Dakota County, we publish a highway map every year, and we just put the grid on top of that. It may not be obvious, But if you really look, this is a wall map, so it's really quite large, 36 inches by 36 inches. And if you look, you can see a VK84, VK94, WK04, VK95. That is the reference into the U.S. National Grid maps for more detail. And so this map is used a lot for a lot of different reasons. And we wanted to make sure that in an emergency situation, we would be able to cross-reference to National Grid maps. So really any maps that you're already making should be National Grid compliant, and you should just put a grid on your map. That's the most important thing. The standard for the cartographic aspects of making these maps is this. You can find it on the web. Just do a Google search for it. You'll find it. It points out how you label the grids, and it identifies this grid zone designation box to specify the grid zone in the 100,000 meter square. And this is why also these grid coordinates are displayed this way, where we have principal digits that are larger, and then we have the less significant digits that are smaller or superscripts. And that's directly related to the U.S. National Grid. I should mention the U.S. National Grid is it's the civilian implementation of the military grid referencing system. So it's been around for a long time. And that makes all of these, any maps that are National Grid compliant are military grid reference system compliant, can be used by the military. And that's why we have these principal digits, because that relates directly to that ability to just use the number of digits that are necessary to describe a square area delineated by the grid. And then we also show how you label the 100,000 meter squares. This is all in that same document, that FGDC document. Shows the variety of grid zone designation boxes. If you're working at a grid zone boundary or the boundary of 100,000 meter squares, I'll be showing you ArcGIS later. That all comes for free. Not the grid zone designation box, but how the grid is represented on the map. Then graticules. Okay, we're talking about UTM coordinates, U.S. National Grid, military grid referencing system, but we do need to also provide a cross-reference to latitude, longitude. This is a georeferencing matrix developed by the National Search and Rescue Committee, and it defines latitude, longitude in the format degrees, minutes, decimal, minutes as the secondary location referencing system for land search and rescue operations. Notice it does specify that the U.S. National Grid is the primary location referencing system. You will notice just below that, though, it shows that for aeronautical search and rescue responders, they will continue to use latitude, longitude in that format, specifically as the primary location referencing system, and U.S. National Grid as the secondary. However, it further states that any aeronautical resources that are supporting a ground-based operation will use the georeferencing location referencing system of the ground-based operation, which is U.S. National Grid. So this all works together. Point is, we need to put degrees, minutes, decimal, minutes on our maps as well. We should have a magnetic declination diagram, and this was something that was actually difficult to do previously, or you had to pay extra to get add-ons for your GIS software to be able to do that. But thanks to Shared Geo, Jim Klassen, creating this resource that's now available. You go to that website and you can just fill in the information that you need, and it'll generate the magnetic declination diagram as an image, and you can copy and paste that into your map. You use the latitude, longitude of the center of your map, and it is time sensitive too, because the magnetic north is moving. But anyway, you can generate this image and paste that right into your map. So that's pretty slick. But along with that, you can also use it dynamically. And so what you'll see when I show you a demo later, I can generate this URL with all of its arguments and have that image generated for every map that I'm creating automatically and placed into the map. So that's huge, because that means now I can automate the entire process of creating all the maps. So it is all about creating maps, but then we've also, while you should just put a grid on any map that you're creating, we've really developed a couple of standards to create some consistency across jurisdiction. And these are two different map series. And so we really think about, while we may have specialty maps and we want to put a grid on it, we can also use the grid itself to create a map series over an entire area. And so that's what I'll be focusing on for the rest of this. And so the smaller maps are we call them 1K maps because it's the 1,000 meter by 1,000 meter squares of the U.S. National Grid of UTM coordinate system. So they are 1,000 meter squares, 8.5 by 11 inches. It just fits really nicely at a scale of 1 to 6,000 on 8.5 by 11 at 1 inch equals 500 feet. It's a real convenient format. Anybody can print them. You print them at home. And 1 to 500 is just a large enough scale to be able to put things like house numbers and street names and fire hydrants and things like that. And you can certainly apply the same principles to any other size maps and other scales as well. But this is the full 1,000 meter by 1,000 meter square of the U.S. National Grid. They also work very well for creating map books. So we can create a map book for cities. What we're actually doing is cranking out a whole bunch of PDF files. Every map is a PDF. They're all named using the U.S. National Grid. It's very easy to just select all of the maps for a given city, print them out, put them into a book, and make a map book. We also take all of the pages for a city and put them into a multi-page PDF with the cover and some other things, and it works very nicely. Files don't get too big, and they're very easy to print and hand out. And then you'll see I mentioned the FGDC standard, and it talks about the principal digits. It doesn't really translate well with larger scale maps like this, so we really had to extend the standards a bit. And realize that we want the principal digits to represent the U.S. National Grid designation for each of the grid lines at that scale. And so this works really well. Here we can just say grid 831511, and we know we're talking about this square in 100 meters by 100 meters. And so it works very well. We always provide, by the standard, we always provide at least one full UTM coordinate in X and Y. You can also see that we have degrees, minutes, decimal minutes, and we've just chosen a convenient increment at this scale. And we put ticks in the map for the gradicules. The other maps are the 10K maps, and this is even 10,000 meter by 10,000 meters of UTM coordinates. These are 22 inches by 24 inches. At a scale of 1 to 24,000 scale. You'll notice that is the same scale that the USGS uses on their 7.5 minute by 7.5 minute quadrangles. 1 inch equals 2,000 feet. So there's good interoperability between the two. Why do we need both? The US topos work well when you're starting from a national level and working your way down using degrees of latitude and longitude, whereas these maps work well when you're coming up from a local level. We're working at a very small area in a very detailed level, and we want to go up and see an overview, and these maps work very well for that. So these are really the two main map series that we've been creating. We created the 10K maps for the entire state of Minnesota, and as I mentioned, that's now led to Steve mentioned the priority for the U.S. National Grid is actually developing and distributing materials for map creation and use. And so really taking what we did in Minnesota and applying it to Wisconsin, and now subsequently applying it to Georgia, has really helped to refine the techniques and the associated data to be able to package this up so that anybody can do it. And we're just using some default base maps and nationally available data sources. An effort like what Stacy is doing with the critical infrastructures will be very useful in refining that. And I think each state might have their own aerial photography sources or their own sources for some of the other information, and maybe some additional layers that they want to add to their maps. So, being able to package this up so that somebody else can run with it and create updated maps or different map series or variations is really what this is all about. Oops, that was a hyperlink. I hope that doesn't go. No, it does. No, that's okay. Not a problem. Not a problem. So it's really about these standardized maps, the 1K and 10K map series. But once you've created one of these maps at these in this size or in this format, it's real easy to just change the scale by a factor of 10 and be able to see 10 times the area. You can have the exact same map layout, the exact same format, and you just change the scale by a factor of 10, and now you have an index map into the larger scale maps, and that works very well. And you can see that here, that same format. You can see the 1K map. We changed the scale by a factor of 10. Now we're looking at a 10,000 meter square, which is an index into the 1K maps, and then you can change it by a factor of 10 again, and now you're looking at 100,000 meter square, which is an index to the 10, which is an index to the 1. Very easily done. You don't have to really change anything but the scale and the foundation of your map series, and works very nicely. So we really automate this, and you know, I've been using the Esri products, and really the original maps in Minnesota are created with ArcMap. There's a tool in there called data-driven pages. Essentially, it's the map series is driven by a polygon data set. So you identify all the polygons that are the foundation. You create the map layout, and then you identify the polygons that are foundation of the map series, and you just tell it to make a map for every one of those polygons. And it just goes. So you just do it, you just make the map once, and then you crank it out and make all these maps. They're all exported as PDFs. I've migrated that from ArcMap to ArcGIS Pro. ArcGIS Pro is the next generation GIS product from Esri. In there, it's called Map Series. It's really taking it to the next level. With ArcMap, you had to add it was an add-in for ArcMap. ArcGIS Pro, it's integrated. And it has some other advantages that I'll point out here in a demo in a little bit. But when you're creating these maps automatically using data-driven pages or map series, there's this concept of dynamic text. And so while the polygons define the map extents for each of the maps, you also have attributes on each of those polygons that can be referenced in each of the maps. And that's where all the power comes in, because now things like the grid zone designation box, referencing the grid zone and the 100,000 meter square can all be automated, because those are attributes on the polygons. So for every map, it's automatically grabbing the value of a particular field for that record and putting it as text on the map. And that can be used for other things. I mean, it's used for the magnetic declination diagram as well. So it's very flexible, and you can just select the polygons that you want to use to make the maps, and it just makes all the maps. Now, it means there's some additional time spent in setting up your polygons so that they have the correct attributes. And that's one of the things that I've really been working on most recently, is trying to streamline that as much as possible. And I'll show some of that here a little bit as well. There are some examples out there right now. If you just do some Google searches, I'm not going to give you the URLs. If you do some Google searches for some of this stuff, U.S. National Grid maps for Minnesota, you'll get to this page. It has been updated to point to some new maps, but we still have new maps were created using ArcGIS Pro, but we still have the instructions and the zip file from using ArcMap. So if you're not using ArcGIS Pro yet, you want to use ArcMap, you can still go here and get the MXD and all the associated data and apply it to your area as well. So it is about getting polygons that represent these 1,000 meter squares, 10,000 meter squares, and so on. You go to usngcenter.org, you can go under library mapping support, and there we've got some instructions and some downloads for creating the 1K map series. And this is all in ArcMap as well. So leave it up to you to explore that, but the instructions are there, and really it's something that we've been using for creating maps in Minnesota. And it'll take you right through the process of downloading the U.S. National Grid data. In this case, these are the 1,000 meter squares, and it talks about what you have to do to set them up to make it all work. But important point here is that, you know, not only do you not have to start from scratch if you want to create these maps, you shouldn't start from scratch. I mean, at least start with what we've already done. If you want to work together and refine this and improve on this, that's great. But let's create as much consistency as we can. Don't reinvent the wheel. There are certainly efficiencies in reusing something that already exists, but it's also less intimidating when you have people that are trying to use the maps and they all look the same. So along with having the grid, there's the same format too. There's no reason, cartographers are like artists and they like to take their own creative license, but for these kinds of purposes, we need to refrain from doing that. Then NAPSG is the National Alliance for Public Safety GIS Professionals Foundation. They created an ArcGIS Pro mapbook template, and it actually uses the ArcGIS Pro tasks, which is a little short of a scripted program to create the maps. Kind of takes you through step by step what you need to do, and then tasks are a little bit, I'd say they're not bulletproof, so it gets a little weird. But if you follow the instructions, it'll take you right through creating a map anywhere in the U.S., creating a series of maps anywhere in the U.S. using a predetermined format. So, encourage you to check that out. That's in ArcGIS. That uses ArcGIS Pro. It was developed originally by somebody. I latched onto it. I think made some improvements to it. Took it to the next level. It's not bulletproof, but it can certainly get somebody started pretty quickly in creating maps using ArcGIS Pro. USNG Center has links to this national grid data as well. So you can go and download the 1K square polygons, 10K square polygons. They are available nationally. These are all available in UTM, so UTM coordinates. So like for Minnesota, I actually had to download 3 different files for the 3 different UTM zones. And that was always a hassle. There's a better way now. And I think we're going to look at what we can do to at least, I mean, this is linked from usngcenter.org as well. But the NGA has published some data out there where they have all 1K squares for the entire US in WGS 84. So that means it's all in lat long, which works great. You don't have to worry about, I used to have to always project it to WGS 84 and merge it all together and all that. You can download the whole US, grab the polygons you need, put it to your own file, and use that for making your maps. They also have the 10-kilometer squares in WGS 84 for the entire US. Very useful. You can see that there is also other supplemental data, so you can get the grid zone polygons, the 100,000 meter square polygons, and it all works nicely together. And I'll show some of that here in a bit. So this was kind of a revelation. It's been out there for a while. I could have saved a lot of time in the past, but I think this is really the way to go, is just grab the WGS4 polygon data sets. Very, 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 very useful. So then I also extend beyond that. So to create these standardized maps, I've also standardized the U.S. National Grid field names and definitions. Now, the stuff that you download from the FEMA site or USNG Center or the NGA site has the essential national grid attributes. So it'll have the full national grid designation. It'll have it'll break it apart into components, and so you'll have the grid zone designation and the 100-kilometer square. That's it's essential pieces of what you need. But I've extended beyond that, and this is to automate some of the things like creating the grid zone designation box, specifically the grid zone designation box, which was always a pain. And so these are just the fields that I've been using, and I just preface them with NG. I use a small number of characters so that it's compatible with shapefiles, which has a limit on the number of characters. I believe it's 10 characters for a field name, and no special characters. So really simplifying it. And shapefiles are also more kind of a de facto standard and can be consumed by a variety of other GIS software. So I think that's important too. But you can just see the names here that I've been using. NG100K, NG10K, NG10K2, where we want to just break out the two character, the two digits that represent the 10,000 meter square. And then you can, in GIS, you can mix and match these things and add them together to create other pieces that you might use for something. But primary purpose is for driving the automated map creation. And then we got a special case, and this was a big problem. One of the biggest stumbling blocks of people embracing the U.S. national grid was the grid zone boundaries, grid zone junctions, because the coordinate systems change. UTM coordinates are unique within a grid zone. So UTM zone 15 has a coordinate system. The exact same coordinate system is applied in UTM zone 14 and in zone 16 and so on. The coordinate system restarts. And so that's why you need to specify which UTM zone you're in. And so it creates a cartographic problem because you have to have two separate grids at that grid zone junction. And you have to represent the grid properly. And then you have to specify it properly in the grid zone designation box. The way I've solved this, what you end up with is partial squares along that grid zone boundary, and you'll see that here in a minute. But in order to keep the map series consistent, I created these pseudo polygons that represent the full square if you were to extend it across the boundary into the other zone. That's only used for the map extents. So that way, if you're working in a certain grid zone and you're working your way to the west, when you hit that grid zone boundary, you're going to see a full map with the same geographic map extents as the previous map, and you'll see the grid zone boundary there, and you'll see the adjacent grid displayed properly. And then you'll be able to make the transition to the maps in the next grid zone. And it all works. The problem was ArcMap failed. It did not handle this problem at all. It was not, we had to really jump through some hoops to get it even close. ArcGIS Pro fixed the problem. It works perfectly, exactly as you'd want it to work. Essentially, you can specify multiple grids, and so you can specify a grid for UTM zone 15, a grid for UTM zone 14, and you can tell it to clip it at the boundary. It labels everything properly. Everything looks good. It's great. So really, if you're not using ArcGIS Pro, highly recommend that you do that. It's a good excuse for doing this. Don't waste your time in ArcMap. If you have a grid zone boundary. If you don't have a grid zone boundary, you're just making maps, you certainly do it just fine in ArcMap. And here we can see an example of that. So here you can see the grid zone boundary, and you can see the grid coming from the current UTM zone, and you're always presenting your map in a specific UTM zone, and that will be the orthogonal grid. And then once you hit that grid zone junction, the adjacent grid is going to come in and it's going to appear to be skewed like that. And that's all because of using map projections to display the round Earth on a flat map. And that's why this happens. GPS devices will automatically make the transition. Any apps that are referencing the U.S. National Grid or MGRS, once you cross that grid zone junction, it's going to switch over, and it all works. So it's not a problem. And if we just look at two maps, so here's one map from one UTM zone, and here's the map from the other UTM zone. And there is that overlap at that grid zone junction. And if you look at, let me see, if you look at them next to each other, if you look at the detail in the aerial photography, it all looks the same. Nothing's getting distorted here. It's just overlaying the grid, the appropriate grid for the adjacent UTM zone. And if we just rotate those a little bit and slide them together, it all works. So it's presented properly. ArcGIS Pro labels it properly. It looks weird for some people, but that's just the reality. And it's just a training issue and a cartographic issue, but it's not an insurmountable problem. It's certainly nothing that should be considered an obstacle. Okay, so I'm going to switch over to ArcGIS Pro. Any questions up to that point? Of course, my remote session timed out. There we go. I'm going to switch my sharing. Of course, the danger of doing live demos, so see how this goes. But I think it'll be okay. So I'm actually showing ArcGIS Pro. Make sure. There we go. So I'm just going to show some of those things that I was talking about. So here is an ArcGIS Pro project that has all that supplemental data. So you can see NGGZD, that's the grid zone designation boxes, and you can see those overlaid on top of North America here. And then as I zoom in, you'll see the NG100K, that's the 100,000 meter squares. So let's see if I can make sure this works. There we go. So as I zoom in, now you see the 100,000 meter squares. Now I'm looking at all this unprojected. So that's why they look kind of like trapezoids. Grid zones are rectangular, but of course that's not true because of the curvature of the earth. It all depends on how I'm representing it here. And I'm just representing it as lat long as rectangular coordinates, which of course is not true. But it really doesn't matter. It's just kind of a caveat that you need to understand. And so then as a result, the grid squares look like trapezoids because they're being projected back to lat long. But anyway, here you can see the 100,000 meter squares. And then as I zoom in, you'll see, and then you can see the 10,000 meter squares, and I zoom in a little bit more, and we're seeing more detail, and I get to the 1,000 meter squares. And if I just click on one of these, we're going to see, let's see, let me go one more level. There we go. Now we've got the 1,000 meter squares. So, here we're looking at a city. So now if I click, it's drilling down through all of those, and over on the right, you can see them. So here are the attributes on the different layers. So let's see. Well, I don't know why that's not updating. Well, anyway, you can see the attributes there. So we've got we're looking at the 1,000 meter squares. I can zoom out and just see the other stuff. So like here, now you're seeing the 100,000 meter squares. You can see the consistent attribute names, field names, and then the attribution that goes along with that. And if I zoom in, you'll see similar attribution. So here we're looking at the 10,000 meter squares. And if I zoom in a little further and click, and now you're seeing the 1,000 meter squares. And this is that full data set. So 15 million 1,000 meter squares for the US, in one data set. But that's slick because I can just do a lasso or use my county boundary to select all of the 1,000 meter squares, export them to my own database, and then use that as the foundation for creating my maps. So you can see the attribution that goes along with that. And then and the problem with the grid zone boundaries is, let me just go. So what I've started to create are the 100,000 meter squares at the grid zone junctions. And so here you'll see that they end up being partial squares. And so the attribution that goes along with that, see if I'll get it here. Yeah, here you can see a number of other attributes. And so now I'm including the grid zone let's see. Yeah, okay. Grid zone designation north, grid zone designation south. I should zoom over to one that's on here like this right here. This should have both populated. And so here we can see for this square, we have the grid zone designation north, grid zone designation south, grid zone designation east, grid zone designation west, 100K east, 100K west, and so on. And then the NG lat, NG long, those are a part of the grid zone designation box as well. And so that's in here as attributes. That is the horizontal and vertical lines here that represent the actual latitude, longitude of the grid zone boundary. And that is represented as well. And then you can see even in the attributes here. So I've got a GZ, DZG, that's the actual text that will be placed in the grid zone designation box. And it has all the formatting and everything so that everything shows up just right. It looked kind of funky here, but it'll actually, you'll see it in a second here. It actually draws it in correctly, in properly. So anyway, if I switch now over to, so this was really, this is all the foundation data, but if I switch over here, now here I've basically used that data to grab all the 10,000 meter squares for Georgia to create, just to start preparing to create the maps. I do have a script here. Where am I at here? Oh, so in here, I create all of these 10,000 meter squares, and then where am I? So state of Georgia has 2 UTM zones, 3 or 4 MGRS or USNG grid zones. So really have to deal with that when we're creating the maps. So it adds some additional challenges, but it's not impossible. And so then what you can see, let's see, if I see, I'm looking at the, you know, building out these attributes, then what you can see is, again, all of that same national grid values that are used for creating the maps. But then there's also the URL for the magnetic declination diagram. So we calculate the latitude, longitude of the center of each of those polygons, and then just do a calc to this other field, MDD URL, which has all of the correct attributes, including the latitude, longitude for the magnetic declination diagram. And then that gets referenced when we make the maps. So that all works pretty slick. But then also create these, you can see in the darker black, these are those pseudo polygons. And so if we look at those attributes, you know, they get out into all these additional fields that are used that I showed you before. But here you can actually see the text tags. And so it's simply, and these are calculated because we have all those other values. So I can just do a calc on GZ-DZG and use the grid zone designation right, grid zone designation left, separated by a vertical bar or piping character, followed by a line feed carriage return, followed by these other text tags for the font size, followed by the NG lat, which is already established. So it works pretty slick. Once you've created all those components, you can just calc all these other values that are used for creating the maps. Okay, so let's look at a map then. So if we come over here, you can see that I've created actually in, if you're not familiar with ArcGIS Pro, they have maps and they have layouts. So you create a map for each of the UTM zones because you have to specify the projection. That's the only reason. So you create the map that includes all the contents, and then really I just copy it to another one and change the projection. So no big deal. And then we have a map layout, and this is where you have all the details. And in here you have a map frame that references the map. And you can see there's a location frame as well. And if we just go look, so that in this case, it's called 10K16. These are for the normal case where we're not at a grid zone boundary. And then I have a 10K17 for the normal case in zone 17. And then I created a 10K16X and a 10K17X. And those are specifically for the ones that are along the grid zone boundary. And if we just go look here at the grid zone box here, you can see, and if I actually just hover over this, you'll see the dynamic text. And so it's using the, and this is all Esri convention, and how you reference these values for each page. So the type is page and the property is NG100K2, and that means it's going to take the value from that field for the polygon that represents the map extents of the map that's being created, and it'll plug it in here. So it just all happens automatically. Let's see. Oh, okay. So you can also see the gridding. I mean, this is another piece here. This is the standard text. The map name again references the grid zone and the 100,000 meter square. Here you can see the gridding. and the principal digits. Actually, if I come down here into the map frame, this is where the grids are defined. And this is the part that's really cool about ArcGIS Pro. Now, it gets more complex, but you can specify the coordinate system for the grid. So whatever coordinate system grid you want to create, but it works very nicely for this. And then you can also specify the components. This looks really complex, but again, it's using all those dynamic text tags. But you can control each of the different components. So how the 100,000 meter grid is labeled, the 10,000 meter labels, 1,000 meter labels, the interior labels or ladder labels for the 100,000 meter squares, and so on. Works very nicely. But in fact, when you add a new grid, you can just pick U.S. National Grid. I mean, I don't know, I wasn't planning on doing it, but you are able to just pick U.S. National Grid MGRS. And once you have everything set, you can save your own template and then just reference that from then on. And so that's really slick. Set up one and then add more grids. Like when we get into the grid zone junctions, you want to have 2 different grids, 2 different UTM zones. And you're able to just use the same template and just specify a different UTM zone. Works really slick. Okay. Oh, and then let's see. Yeah, I'll show that in a minute. You can also specify to clip to UTM zone boundary, and that's the key as well. And when we created these maps, you see the legend. Oh, I didn't mention that, but I did say that I'm just using nationally available data sources. This is just referencing, I think they're actually Esri REST services from the, I think it's from NGA and the national map for police stations, fire stations, all of those things that you see there. And this is where, Stacy's working on, she recognized the problem with these national data sets, and we can improve on that. And then we can just plug our own layers in for Minnesota, as can, anybody else. And we left some room over here in Minnesota. We actually had a whole legend over here on the right in that big white space there. So we put in like state park boundaries and other park boundaries and things like that. So that's open for anybody to use if they wanted to add something else. Okay, so then I want to get 10 minutes left. So I just want to go to show this thing with the grid zone junction. So here you can see, barely maybe, but you can see the darker line down the middle, and that's the grid zone junction. And so here, everything was the same, but once again, now if I go look at that grid zone designation box, now you can see how that text looks. And that is just the value of that field, NGGZD. You can see it right here. And it formats properly. It's a really slick technique. And I got to give Allison Slatz credit for coming up with that, because she did that with the Minnesota maps originally. So that's really a pretty slick way of doing this grid zone designation box, which it was a pain to figure out before, but having it all driven by data like this just makes it all automatic. And then of course it's how do you create all of that, and I did want to show that here in a minute as well. Let's see. So let me go back. Zoom to page. Okay, I wanted to go back here. Well, we already looked at that. I think we're pretty good. Oh, I was going to show the grids. Okay, so in here you can see I've actually added, because the next step here is to create some kind of a template that anybody can use anywhere in the US. And so I thought, well, I can just make all the grids. This is actually a technique that you'll find if you go play around with that NAPSIG project template. Did the same thing there. Defined all of the grids, so it'll just work wherever you are, and it's going to clip the grids to the grid zone boundary. So whether it's displayed or not in the map doesn't matter. whenever your map extents change to another UTM zone, it'll automatically clip it properly. And so that's where you can see this. And if I just go look at the properties here, I was just going to point out, there's this checkbox right here, clip to UTM zone boundary. And that's the magic. That's the magic. And you can actually see how that happens right there. Let's see, wait for that to refresh. Come on. Okay. But then it does the correct labeling. You can see that it's labeling in the interior. And so you can see the grid lines labeled there properly. And then around the perimeter, they're labeled properly. And you should even see, if I get to one, oh, you can just see it up in here. There it's showing the 100,000 meter squares. So I was talking about the map series, and that's all in here. So here's just how you set up the map series. And you just specify a polygon data set that is the foundation for your map series. That's not, oh, there we go. And so there, I'm just specifying the layer that's used. And then you can do some other setups for the pages and things like that, specify the map extents. We want to have a consistent scale for every map. You can have it zoom. These could be irregularly shaped polygons for doing a map series if you wanted them to. I don't know why you would do that, but it works really well doing it this way. Oh, I know. That's what I was going to show was for creating all this data, we had to do that. Let me see. I need to, whoops. I just wanted to show this real quick. Let me, this works better if I do it like that. So if you look at these 100,000 meter squares and the attributes that are associated with them, what you can see is that it has all of the attributes that represent those different pieces that are needed. So these are the 100,000 meter squares. The maps are based on the 10,000 meter squares. But what I realized, I used to, you had to go in and set all of that, and there's some shortcuts you could take and things like that. But by having this available nationally, what we're able to do is use, oh, that was the other part, is how you create those pseudo polygons. There's a tool called FishNet, both in ArcMap and in ArcGIS Pro. FishNet allows you to specify coordinate extents, and then it basically creates polygons of a certain size based on what you specify. So works really well for creating all those pseudo polygons. But then what we can do is just do a spatial join of those polygons with this NG100KX, and all of these attributes get copied right in to, with the same names. And so the map templates will just work. So it's a real slick thing that we're going to be able to do. And I'm just finishing that up. What I intend to do is package that up as a ArcGIS Pro template. I'm going to work with Steve to get this data pushed out to USNG Center. And it's just, and then write up the instructions for how to do this. But it's going to eliminate any reservations that people had about having to map across the grid zone junctions, because it'll be a step-by-step procedure, maybe some Python scripts or something like that, but it's really pretty slick. The other thing I found in ArcGIS Pro, the Python scripting, every time you use a tool, you can go look at the history, and you can do a right click and grab the Python command that was used for that and save it. And so if you want to rerun it, it's really easy to just plug that into the command line. So that's another nice little tip, is paying attention to that. That works really slick, especially if you start doing something repetitively rather than working through the dialogues. So I think I'm out of time. I know there was a lot real fast. There will be some stuff coming. I'm going to package this stuff up neatly with some documentation. That's my objective right now. Generating maps for Georgia in the process, and I'll probably have to test it out somewhere else. I'll probably come back and test it on Minnesota again, recreate those maps. So Any questions?
So Randy,
I see a question.
all right.
Should all layers in Pro be in the same projection and coordinate system as the USNG grid? No. You can, in Pro, your data can be in whatever coordinate system as long as it's defined. And then you define the map projection for your map, and then everything gets projected on the fly. So no, as long as it's a known coordinate system, you can mix and match and everything gets projected on the fly.
So Randy, you do have a question that we historically have heard over and over again. Why would you want to do this over
I got a slide for that.
Yep.
I got a slide for that. It's not intuitive, first of all. I mean, we do reference it. It does need to be referenced in our maps, and we do need to be interoperable using it. The bottom line is that lat long is not a rectangular coordinate system. It's a base 60 system. It's not a base 10 system like UTM coordinates. Lat long does not represent any kind of a projection, a map projection. So if you use lat long as a rectangular coordinate system, everything looks distorted. So that's not good. Plus, as a base 60 system, you don't really know how big a degree is, and really degrees of longitude, degrees of latitude get smaller as you get to the pole, or the other way around. Degrees of longitude get smaller as you get to the poles, where they finally converge. And so, you can't measure. I mean, obviously there are apps out there that'll give you a distance between two locations in lat long, but you're not going to be able to visualize it by just seeing it. It's counterintuitive. It's difficult to know if you're representing enough precision, and because of the multiple formats, if the person that's receiving your information about a latitude, longitude, location is not receiving it in the same terms, they could be off by 50 miles. And there are actual cases, emergency responder cases out there where the helicopter went to a location 50 miles from where they were supposed to be because they misinterpreted the lat long. Need anything else? Who was that? I'll take my gloves off and we'll talk more. But it's a standard question. It's a good question. It's a legitimate question. And as geospatial professionals, we need to be prepared to answer it because it comes up all the time. And I've got some slides on it. We address it all the time. I didn't do it today because I didn't have time. Thanks for asking, though.
Okay, so Patrick, and I think your last name would be pronounced. Oh, did we lose him?
No, I'm still here.
Okay, Patrick. Yeah, thank you for that question also. So the whole idea on the federal level was to try to, if you will, establish an emergency response language of location. Across the emergency services sector, there has been a long history of, much like the military, trying to create standards which would facilitate if the uniformed services, a uniform way of handling whatever circumstance it might be.
Simply referencing the fact that it was developed by the military to eliminate the problems caused by lat long.
Yeah. So I was going there. I was going to tell
sorry about that.
Yep. That after the Second World War, the U.S. Armed Forces and NATO got together and they basically said, we got way too many people killed using latitude, longitude because of some of the reasons that Randy related there, 3 different versions, the lack of specificity that you can create without having a long latitude, longitude string. One of the things that Randy did not mention, because we tried to focus more on the GIS side of this, is with as few as 8 digits, that's 2 less than a full phone number or 1 less than your social security number, you're able to relate a location with 33 feet or 10-meter accuracy within an area that's roughly 62 miles on either side. And so that that level of simplicity in the emergency response world, to the degree that you need to use verbal communication to relate location, that simplifies things a great deal. That's why.
Well, even beyond that, Steve, you know, by using less digits, it implies a precision, and you're referencing an area. And so if you're specifying an LZ for a helicopter, you're probably good specifying it to a 100 kilometer square, or even 1,000 or 1,000 meter square, or 100 meter square, or 1,000 meter square.
Yeah,
So,
there you go.
you know, but just by specifying 4 digits, you know, you're getting to a 1,000 meter square, and then look for the flashing lights, you know.
Yep.